Okay, so what we're going to do now is we're going to do something very similar, but we're going to try to simplify things in radical form instead of its fractional exponent form. But what I'm going to do is I'm going to do it in both ways to show you that you get the exact same answer. So the first thing we need is this rule over here, where if we have at least one of them, in this case A, is positive, and you have the same radical, what you can do is you can write it under one radical. So the same radical, you can write it under 1 as a multiplication. Now what I'm going to do is I'm going to give you an example to show you that it doesn't work if both of them are negative. So for example, the square root of 4. We can rewrite this as -1 times -1 times 4. Right? So we have two negatives here. If you want, instead of this -1, just write it as -4. So we have two negatives here, right? And what this rule says is that we could split it, right? Either going from two radicals into one or from one radical into two different ones. So I went from one radical into two, but the square root of -1 is I, right? So we remember that I is the square root of -1. This one, though, we also know is I square root of 4. Well, this gives us I squared. Well, I squared is the square root of -1. So if I square that, because the I value, this part right here is square root of -1, you get -1 times the square root of 4. So what you said here is that the square root of square root of 4 is equal to the negative square root of 4, which is not true. So you cannot do this if there are two negatives multiplied to each other. There can only be one, at most one. So let's do an example where we do radicals, the radical version and the exponent version, just so we can see that they're the same. So what we're going to do in these problems is we're just going to assume that the inside of the radical is already positive, so that we don't have to worry about the restriction of at least one of them is positive. So here we have a multiplication. The radical is the same, they're both 2's. So I can rewrite it under 1. So that's the first one, multiplied to the second one. Multiplication of fractions says multiply straight across. So these cancel, and so does this. And all you're left with is the square root of x. Now, it depends on the situation, radical form versus exponent forms. Some of them are easier at any given time. My personal preference is to use the exponent form because it's actually why these things work. So if you look at this one, you get 2x over 5 all to the half to the half. But we know our exponent rules distribute under multiplication. So we get 2x over 5 times 5 over 2 all squared. All to the half power. Because the half will distribute to each part of that product. These 2 cancels, these 5's cancel, and you're left with x to the half, which again is the square root of x. So they both give you the same answer. It doesn't matter which one you do. I think the radical version of it is useful when you have to calculate something. So like if x plus 4, finding the square root of 4 is easier than finding 4 to the half power. But I think you'll find if you get into later math classes that the exponent form is actually going to be easier to use